Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaku. So now we are starting this live stream of O Level Maths, and our focus is on paper one. And nowadays in the new syllabus, there is very little difference between paper one and paper two. So paper one and paper two, they are almost the same thing, except for the fact that this is non-calculator and the other one that is calculator version. As far as the difficulty level is concerned, it is exactly the same. So now, unless and until you have appeared in paper one, you don't know which topics will be coming in paper two. So therefore, technically, you have to prepare for everything in paper one. So now we know that it's a 2 hour paper, it's for 100 marks, and there are three categories of question. There is the easy ones, the moderate ones, and the difficult ones. So therefore, let me mark it down. That is the easy one, the E category, the moderate ones, the medium level of difficulty, that's the M category. And then there will be something difficult or tricky. So that is the D category. So now remember this thing, that 2 hours is 120 minutes and we have 100 marks. So 100 marks, that means you should be able to do 100 marks worth of working in 100 minutes maximum. And yes, this is achievable. So now over here, this thing is possible, that 100 marks is achieved in 100 minutes. That means how many minutes are you left with? So you are left with 20 minutes. That is the time that's remaining for you to relax, for you to recheck things, and so on. So all these things are possible. Now, if I divide the syllabus into different categories, and we will soon, what is the objective over here? Yes, let me first write it down. We will be reviewing the topics, and we started at 9 p.m. And I think we will go at least till 12 or 12:30 a.m. So that is like 3.5 hours kind of work that we will do. So minimum, it can also go up till 4 hours. There is no limitation. It all depends on your stamina. How much stamina do you people have? So now reviewing the topics, that is one objective. The second objective is going through nice questions from different year papers. Maybe it could be 2022, it could be 2023, it could be 2024, it could be 2025, it could be a collection of these things. Nice questions from these. And then focusing on the demand by the examiner. So the examiner has set up a paper and there is a certain demand of that paper. So what exactly is the examiner asking for? We will go over the syllabus. We will go over the questions that is already focused over here from these papers. And basically, that's about it. Of course, that is tips and tricks. Technically, the do's and the don'ts. We will go over the examiner's report. Very important, much important than the mark scheme. And then some advice, suggestion, instructions that you need to follow so that you get the A star that you deserve. So now, first of all, if I divide it into different categories, the syllabi. So let me focus on different topics. So this is one, then this is two, then there is three, just breaking it down. And then there is four, and then there is five. Let's divide into five categories. If anything is left, we will double check. So now what we need to do is that the first thing that I need to focus on, that is numbers. So numbers are very, very important. The old terminology for number is arithmetic. It's much more than arithmetic plus. We talk about percentages, we talk about ratios, we talk about time, we talk about what you call currency. So there is dollars and pounds and PKR. We talk about what you call, let's say, the squares and square roots and the cubes and the cube roots kind of thing. And then basic mathematical operation, bracket of division, multiplication, addition, subtraction, things like that. And some other small things that all fall into this category, that is numbers. So very important. The next thing that's very important is algebra. So algebra is the heart and soul of math. So we talk about expansion. We talk about factorization, very important. We can talk about what you call indices. Graphs is also part of algebra. With graphs, there is sketches and word problems, quadratics, completing square method, and all these things that fall under the category of algebra. Then I can talk about mensuration. So mensuration is about 2D figures. It's about 3D figures. In 2D, we talk about area and perimeter. In 3D, we talk about surface area and volume. And now we have a formula sheet. So most of the major formulas are already over there. And we can then talk about geometry. So in geometry, we can talk about angles of different types. We can talk about polygons. And what else can we talk about? We can talk about circles, circle properties, whether it's the circle property, the tangent property, all these things. Then we can talk about symmetry. We can talk about similarity, and congruency is no more. Now, in numbers, we can also talk about sequences. Either it falls into the category of arithmetic or algebra or both. So these are some of the major topics of geometry. Then we can talk about statistics, and let me add probability with it. Technically, that's divided into two categories. Let me dump it all in. We can talk about diagrams, whether it's a pie chart, whether it's a bar chart, whether it's a pictogram. We can talk about frequency distribution. So based upon frequency distribution, we draw a histogram. Based upon frequency distribution, we can calculate the mean. We can talk about cumulative frequency distribution. So we can draw a graph. We can calculate a median, lower quartile, interquartile range, upper quartile, 90th percentile, just to give you an example. And things like that. And yes, there could be mean is already taken care of, and then median and mode. And some basic common sense question. And yes, relative frequency is also part and parcel of this. So let me write over here that is relative frequency. In probability, so if I remove probability from here, so let me just change to the next one. So if I remove probability from here, let me add it someplace over here. This causes always the trouble. So now if I talk about probability, so that is with replacement, without replacement, tree diagram. Then there is sample space diagram. Or sometimes they can just use common sense probability. And technically, relative frequency is also probability. What else is there? So now if I talk about what you call vectors, and transformation. So let me fold that into one category. So this is vectors and transformation. So vectors, that is related with coordinate geometry. And yes, let me make another box for coordinate geometry. So that is over here, coordinate geometry, CG, the basic thing, distance, midpoint, length, that's the same thing as distance, slope, equation, parallel lines, perpendicular lines, perpendicular bisector. And this coordinate geometry can also be changed into vectors. So vectors, that thing is there. Magnitude of a vector, position vector, length, that is magnitude. The vector AB, which is OB minus OA. And then there is similarity in vectors. Similarity is also there in mensuration. And did I write symmetry over here? Yes, I've written symmetry. So now transformation, there is rotation, there is reflection, there is translation. And what's the fourth one? That is enlargement. So technically, that is the whole O-level math syllabus. Maybe if I have forgotten anything, we will just double check with the syllabus. So there is numbers, there is algebra, there is mensuration, vectors and transformation, geometry, stats, probability, coordinate, geometry. So now let me just double check if there is any comment or something. So, okay, let's move on. Now, first of all, let me go to the syllabus. I think that should be the one. So syllabus was over here. Okay, that's the syllabus. So now when we look at the syllabus, and that is the main thing, the content overview. So let me just copy this thing. Trigonometry, yes, that is a major thing that was skipped. So now let me just write over here. So now numbers is taken care of. Let's tick mark one by one. So numbers is taken care of, algebra and graphs, coordinate geometry, geometry, mensuration, transformation and vector, probability and stats. And the only thing that I left out was trigonometry. So let me add one thing over here. That is trigonometry. So now trigonometry, that is right angle trigonometry, that is Pythagoras, that is sine, cos, tan, then non-right angle, and there is sine rule, cosine rule, area as half AB sine C, Over here, area is half base into height. That is already part of geometry and all these things. And then shortest distance, 3D trigonometry, elevation, depression, and what else? Bearing. So that's the whole syllabus right in front of you. So now there are different approaches that I can apply. Let me first get started with some topical thing. Let's say this is topic number 9, that is statistics. And let me just copy this thing. And let me add a page over here. And let's look at the syllabus. And it will be a good reminder for you. What exactly have you done? What needs to be focused on? So now over here, classify and tabulate statistical data, tally tables, the one with 4 ticks like this, 1, 2, 3, 4, that's a tally table. Two-way tables, some information is given. And then read, interpret, draw inferences from tables and statistical diagram, compare sets of data using tables, graph and statistical measure, that is mean, median, mode. Appreciate restrictions on drawing conclusions from given data. Yes, one other thing, the scatter diagram. So I think that I did not mention over there. Mean, median, mode, range, the difference between highest and the lowest value. Estimate for the mean. For grouped discrete or grouped continuous data, what does it mean? When we have values like this, 0, 1, 2, 3, 4, and corresponding frequencies 7, 9, 11, 5, and 3. So this is called discrete group data. And grouped continuous data would be something like 10 to 19, 20 to 29, 30 to 39, and then corresponding frequencies are given. That's the thing. Statistical data, the bar chart, the pie chart, the pictogram, the frequency distribution, and so on. And then we have this thing. And let me add a page over here. So now we have all these things. That is scatter diagram, positive correlation, negative correlation, zero correlation. So positive correlation is a positive gradient. Negative correlation is a negative gradient. Zero correlation, so it's neither positive nor negative. It's all spread out. There is nothing over there. That's a zero correlation. Cumulative frequency, we all know, and histogram, we all know. So now what we can do is that whatever we have studied so far, let's go to a particular paper, or maybe more than one paper, and let's see if certain questions are already there. For example, over here, this thing is there, and you can have a look at this. It says the heights of 80 plants is measured. The table below shows the result. So h is less than or equal to 2, h is less than or equal to 4, and that's cumulative frequency is already given. So now, if cumulative frequency is already given, we can do the plotting. We know that cumulative frequency goes on the vertical axis, and this thing, the upper class boundary, goes on the horizontal axis, and so on. That is how you join the points. So that basic knowledge you have. Use your diagram to find an estimate of the interquartile range. Lower quartile, let me get this thing. Lower quartile, that's 25% of cumulative frequency. It's ending at 80. Yes, it's at 80. And also double check. Sometimes they might write 100 over there, and this ends at 80. So you have to take care of that. So now 25% of 80 is 20. Go to 20, touch the graph, read off the value. That's the lower quartile. 75% of 80 is 60. Touch the graph, read off the value. And that is the upper quartile. And hence the difference between the two, that is the interquartile range. Got the idea? So now over here, where are the points where people can make mistake? That is what we are discussing over here. That is, the pencil should be thin. So pencil should be thin. That is one thing. And the second thing, when you mark these points, make it obvious. So sometimes people forget these crosses and they don't make it obvious. So make the points obvious like this. And then don't overthink. So don't overthink. Okay, will my answer match that of the examiner? The examiner knows that a human is doing this question. So don't overthink. Just do your level best and you're all set. Now, what about this thing? That is, plants are sold when they are taller than h. 28 of these plants are sold. Find the value of h. So now there is a certain value. And we can say that the total is 80 and 28 are taller than h. Then 80 minus 28 is what? 52. 52 are lesser than h. So the keyword is lesser because it's based on upper class boundary. So technically, you are changing the statement. Plants are sold, they are taller than h. 28 of these plants are sold, therefore 52 are shorter than h. So now I'll go to this value 52. I'll touch the graph. I'll read of this value. This value is 6.8. That is the answer over here. That same thing can be applied over here, the concept of percentile. That is 25% of cumulative frequency is 25th percentile. 25% of the people are scoring below this. Upper quartile, that is the 75th percentile. 75% are scoring below this. Median is 50th percentile. 50% are scoring below that. So if your A grade is on the 90th percentile, that means 90% people are scoring below this. You belong to the top 10%. And A star is on the 95th percentile. So 95% of the people are scoring below this. The top 5% are the top 5%. You are in the top 5% if someone scores an A. So now some people are saying that if they have not taken any workshop, क्या उनका इस क्लास से कवर हो जाएगा? I'm trying my level best. Inshallah, hope for the best. Just pay attention right over here. Don't overthink. So that is the main thing over here. Now, let's say if I look at this frequency thing, a farmer records the mass of each of his sheep. Some of the results are summarized in the table and illustrated in the histogram. So that is the frequency distribution. And frequency density is there. So we know this concept. That is frequency density. If we make it thinner, frequency density is class frequency over class width. So now over here, the frequency is A. This is 15 till 20. So therefore, the class width is 5. The frequency is A. And 15 till 20, that is 15, that is 20. This 6 is the frequency density. So 6 frequency density is frequency A divided by 5. Therefore, A comes out to be 30. So remember that area of bar represents frequency. Why? Because the height is frequency density. This thing is class width. So frequency density into class width. Frequency density into class width is what? Class frequency. So that is the major thing over here. And then you complete the histogram by calculating more frequency densities. Now, let me go to the idea of probability. So let me first, let's say if the syllabus thing is there. And let me add a page and let me read a bit about probability so that you all sit. And we are going slow and gradual. So people don't overthink. Right now, your intention should be that I'm attending this class. There are no distractions. That is the reason I don't even open up my camera, so that your total focus is on the page that's right in front of you. And as far as the comments are concerned, I'll watch very, very little of the comment so that my full focus is over here because I don't want to get distracted also. Yes, we will take a break, maybe after 40 minutes, 45 minutes, a 5-minute break, and then another break, and then another break, and so on. So just relax, sit back, and chill. So now it says probability. Now it says understand and use the probability scale from 0 to 1. So probability can only lie between 0 and 1, whether it's in fraction, whether it's in decimals, whether it's in percentage. They all are classified as probability. Understand and use probability notation. Probability of A is the probability of event A, probability of getting a head on a single toss of a coin, probability of getting a 6 on a single roll of the dice. Calculate the probability of a single event, and over here, probability of A complement, that is not A, not getting a hit, not rainy, and so on. Probabilities should be given as a fraction, decimal, or percentage. I think the examiner read my statement. Problems may require using information from tables, graphs, or Venn diagram. That means probability is also associated with sets and Venn diagram. So yes, they are connected. So I think in the list over there, a Venn diagram that falls into the category of numbers. So it's also related to probability. Understand that the probability of an event not occurring is 1 minus probability of that event. It means probability of A complement not occurring is 1 minus probability of A. Probability of B is 0.8. Probability of B complement should be 0.2. Relative and expected frequencies. Relative frequency is an estimate of probability. We don't care. We just treat it as a probability. We just treat it as a fraction. Expected frequencies, that is expectation, is this relative frequency multiplied by total. Just remember this formula. Feel free to take screenshots. And if you have my WhatsApp number, you can also ask me things over there. You can ask it from your friend or DM me on Instagram. Not right now, later I can answer that. Probability of combined events, whether it's about sample space diagram. We are rolling 2 dice, 1, 2, 3, 4, a 4-sided die, 1, 2, 3, 4, and then we are talking about a sum. That is what we mean by combined event. Venn diagram, probability of A intersection B, that is common. Probability of A union B, take all without repetition. And then we can talk about tree diagram. So if I talk about, let's say, event A is 1, 2, and 3. Event B is 2, 3, 4, and 5. So A intersection B is what's common, 2 and 3. And A union B, that is take all without repetition. So it's 1, 2, 3, 4, and 5. And let's say there is a universal set that is 1, 2, 3, 4. Let me erase this thing for right now. 1, 2, 3, 4, and this is 5, and this is 6. Okay. So now we can say that if I draw a Venn diagram over here, so let me draw a box first. Let me remove the color. Let me draw a circle over here. Let me draw another circle over here. And let me remove the color. Now let me write over here, this is A, 1, 2, 3. This is B, 2 and 3 is common. This is 1. And this 2, 3 is there. This is 4 and 5, and this 6 on the outside. So basically, this 6 is A union B, the whole thing complement, that is 6. Got the idea? So now let's look at some questions. Let me first copy this. And let me write it over here, paste it over here. First, have a look at this thing. It says there are 10 cards in a set. Each card shows either a square or a triangle. Then it says every shape on each card is either a green or a red. So now this is like a table. So how will we read it? We will read it like this. So we will say there are 3 green squares. There is 1 red square. There are 4 green triangles, and there is 2 red triangles. The table shows the number of cards of each type. So it's based on color, it's based on shape. So this is shape and this is color. Ken takes a card at random from the set, notes the color and replaces it. That means the total will not change. He then takes a second card at random from the set, notes the color and replaces it. Find the probability both card shows a green shape. Now, how many total greens are there? That is 7. So this is 7 out of 10 into 7 out of 10. That is probability. This is happening and this is happening. So and means multiplies. I'll show you the solution very soon. Now it says this person, Irina, takes 2 cards at random from the set of 10 without replacement. So first denominator is 10. The next denominator has to be 9. Find the probability both cards show the same shape. So now it's based upon shape. How many squares are there? 4. How many triangles are there? 6. So it could be square, square, or it could be triangle, triangle. So square, square would be 4 reducing to 3. Triangle, triangle would be 6 reducing to 5. The denominator is 10 and 9 and 10 and 9. I hope you got the idea. Let me show you the working. First of all, there are 7 green, there are 2 red, there are 4 squares, there are 6 triangles. Both show a green shape. So this is 7. Replacement is there. The color of green does not change. The total does not change. So 7 over 10 into 7 over 10, that's 49 over 100. And people in the comments, yes, you can just put a tick mark, those people who are watching, that this is all good, all clear. And now over here, if we talk about a square, so this 4 becomes a 3 because 1 square is reduced. And if we are talking about a triangle, 6 becomes a 5. The total 10 becomes a 9. The total 10 becomes a 9. And make a habit of probability. What needs to be taken care of? Do not reduce the fraction until the very, very last step, and only reduce if asked for in the very, very last step. Do not reduce in between. So that is a very, very important piece of information, instruction that you need to follow. So now these kind of things, just giving you some idea over here. Now, let me show you some other kind of work. Okay. So now this is relative frequency. Again, let me first let you read the question. And if you want, you can also try it out. Yes, there is no harm. The live stream will keep on going and you can try it out. Okay. So now it says 100 adults were asked about the color of the car. The results are shown in the table. The color of the car, red, black, blue, silver, and then the corresponding frequencies are given. Write down the relative frequency that one of the car is blue. So this 11, that is the numerator, and 100 is the denominator. So this is just like a fraction. This is a probability from a frequency table. So probability from frequency table, I call it, or the examiner calls it, frequency, relative frequency. That's all about it and nothing more. Now, a different group of 1,200 adults were asked about the color of the car, the relative frequency of this white car, because white is not mentioned, is 0.3. Find the number of these adults who own a white car. So just take the relative frequency, multiply it with the total, and that will be answer. That is 3 into 120, that is 360. Double check. From over here, what they're asking for blue, blue is 23, 23 divided by 100. I coincidentally picked out 11. No, accidentally picked out. So this is 23 over 100. Now over here, 1200 into 0.3, that's 60. And we can also work it out this way. Using ratios, 3 out of 10, W out of 1200. So 3 over 10, that is W over 1200. And then you get 360. Also, you can do the cross multiply method. So two methods of ratios, one method of this thing. Why don't you go ahead and take a screenshot? Let's move on. Now, let's talk a bit about transformation. So let me copy transformation. The syllabus over here. And we will just be going over these 2-3 things and then go to the past papers and first focus on these things. So transformation, recognize, describe, and draw. So maybe it's about looking at the diagram and giving answer, describing it, or the examiner is asking you to draw it. So now over here, reflection of a shape in a straight line. That straight line could be the y-axis, that could be the x-axis, that could be the line y is equals to x, that could be the line y is equals to negative x, or any other line. Rotation of a shape about a center through multiples of 90. That means 90-degree clockwise, 90-degree anti-clockwise, and it's also this thing that is 180 degrees. Now, if they ask and if they write 270 degrees, 270 degrees anti-clockwise, that is the same thing as 90 degrees clockwise. Because we are going like 90, 180, 270, that's the same thing as 90 degrees clockwise. Enlargement of a shape from a center by a scale factor, translation of a shape xy. So 7.1 is just transformation, and then they talk about vectors in the same syllabi, in the same component. Describe a translation using a vector represented by such and such, add and subtract vectors, multiply a vector by a scalar. Magnitude of a vector. Vector geometry, this is important. Represent vectors by directed line segments. Use position vectors. Use the sum and difference of two or more vectors to express the given vectors in terms of two coplanar vectors. So that is vector A, that is vector B. That is what they mean by it. Use vectors to reason and solve geometric problems. Show that vectors are parallel. Show that 3 points are collinear. Some vector problems involve ratio and similarity. So this is the climax of vectors. That is 7.4. That is this thing, and that is what is described over here. So now this thing is the same thing over here. Let's first talk about transformation. Let me just copy this. So each question, I'll first show you the question. And then we will talk about the solution. So that is the question, that is the solution. Now I have minimized it. Why don't you go ahead and first read the question? So I'm just shifting my place a bit. Okay, people. So now we can look at this. It says the diagram shows triangle A and B. Describe fully the single transformation that maps A onto B. Now, the thing that you have to look out over here is this thing, that this triangle had a base of 3 units, the original one, that is A, and the height is 1 unit. Height is 1, base is 3. But when it is transformed, now this thing, the base became the height, and the height became the base. So now when such is the scenario, that height becomes the base and base becomes the height, that is a 90-degree, either clockwise or anti-clockwise rotation. That is the first thing that you need to understand. So let me just bring my mic a little bit closer. So that is the kind of working that you need to think. Now, since we can very well see that this moved not this way, it moved this way. So therefore, this is 90 degrees clockwise. Now, before I proceed, let me first tell you the kind of working that you need to look for. That is, whether it's about rotation, whether it's about translation, and so on. So let me make 4 boxes over here, or 4 circles over here. So that is the first circle. Let me paste it over here, another one. Let me change the color. Then there is a third one. And let me paste a fourth one. Okay. So now over here, what do we see? We see that there are 4 things that we need to consider. And let me just do some adjustment over here. Okay. Now over here, let me first write about reflection. So when we write about reflection, what things comes to mind? That is reflection in x-axis. Then it's reflection in y-axis. Then reflection in line y is equals to x. Reflection in line y is equals to negative x. These are the 4 standards. Anything else, we just do it by counting the squares. Reflection in x-axis, a point such as AB, when it's in the x-axis, y coordinate changes. So A and negative B. When it's in the y-axis, a point such as AB will become negative A comma B. So this is 0.5. Okay. When it's reflection in the line y is equals to x AB becomes BA. So over here, coordinates flip. Coordinates flip, nothing else. When it's reflection in the line y is equals to x, AB becomes negative B, negative A. Coordinates flip, sign flips. Both things happen. So now that's the litmus test that you need to remember. Now, when we talk about this thing, which is over here, which is about, let's talk about, let's say rotation. And center of rotation is the origin. If it's the origin, there is 90-degree clockwise. So AB, first of all, height, base, height. So it will be B and negative A. If it's 90-degree anti-clockwise, so AB will become negative BA. And I'll write down these statements. 180-degree doesn't make a difference clockwise or anti-clockwise. AB will become negative A, negative B. Now, first of all, you will write over here, coordinates flip, and new Y coordinate changes sign. Over here, you will write coordinates flip, and new X coordinate changes sign. And over here, coordinates do not flip. There is only sign change. Now look at these two very, very closely. Reflection in the line y is equals to x, coordinates flip. Reflection, actually rotation 180 degrees about the origin, only sign change. The combination of these two is this thing. Y is equals to negative x. Not only the coordinates flip, there is also the sign flip. Over here, when you are moving clockwise, so first x and y were both positive. Now x is positive, y is negative. That's the logic. When you are moving from first quadrant to second quadrant, now y is negative. Now x is negative. So x is negative. So that is the thing that we are focusing on. Now the third one, that is what you call translation. That is the simplest of the all. And that is a very easy concept. That is, if the original point is AB, and this becomes a C and D, and the TV translation vector is HK, how are they related? So AB plus HK is equals to CD. If H is positive, it moves to the right. If H is negative, it moves to the left. If K is positive, it moves up. If K is negative, it moves down. That is the basic logic. And then we can talk about enlargement. Enlargement, scale factor K, and center of enlargement is the origin, that is 0, 0. So a point such as AB will become KA, KB. And there is this thing, area of image is K square times area of the original thing, that is the object. So object stands for original and image stands for final. Okay, so now this is the summary over here. Now over here, we know that this thing is happening, but now there is something else to consider. This is 1 and 1. So this is becoming 1 and negative 1. This is 4 and 1. It's becoming 1 and negative 4. So yes, we can say based upon this, coordinates flip, new y coordinate changes sign. This is 90-degree clockwise rotation about origin. That is the answer for this one. So I have marked corresponding points. The red is red and the blue is blue and the green is green. And we can just see it right away. So that is a simple thing. Something like this. There is shape A, there is shape B. And they are saying, describe fully the single transformation that maps A onto B. Now, the height of A is 1 unit. The height of B is 2 units. So we know that the scale factor is 2. But now the question is, what is the center of rotation? So we join corresponding points. So we join these 2 points extent. We join these 2 points and extent. Where it meets, that's the center of rotation. So let me do it for you. So it was not done properly. So let me just join the lines. So now over here, not this thick. And for calculation purposes, that's very, very thick. Okay, now that's not that good. Okay. And let me take the blue line from this corner. So now where the lines merge, that is the center of enlargement, which is these two are joining, these two are joining. So this is 1 minus 1. So this one doesn't look right to me. This is 1 and negative 1. Where they converge, that is the answer. Draw the image of the shape after 180-degree rotation. So apply this concept, which I just told you about. Now this one, another nice question. Let me just copy this thing. First paste it. Now it says shape A, and shape A, P and Q are drawn on a centimeter square grid. Now someone has written a comment. I'll do some examples and then look at the comment. Shapes A, P, and Q. So A is there, P is there, Q is there. So P and Q are triangle and shape A is just another shape. Describe fully the single transformation that maps P onto Q. Now this thing over here, that is P has a base of 1 and height of 2 units. Now the tables have turned. This has a height of 1 and base of 2. So we know that this is a 90-degree clockwise rotation. But the question is, what about the center of rotation? This is 5, 1. This is 1, negative 5. So center of rotation is the origin. So center of rotation is the origin. If it's something else, then what do? We join corresponding points, this with this thing. So first of all, this step, let me just mark this. So that is this red one. If it was some other point, we join these two. And then we join this thing, this with this. And we draw perpendicular bisectors. So I think someone asked the question about this thing. So would we use perpendicular bisector to figure out the center of rotation, or is there an easy way? If the center of rotation is 0, 0, that you can find from the concept I described. Otherwise, you can use the perpendicular bisector way. There is a calculation way also, but that I'll tell when we will be doing some questions. But for right now, drawing is the best way. Some people also use tracing paper. So now over here, what's the scenario? The scenario is that if this was the case, what we would do is that we would join the corresponding points. Let me join it like this. Draw the perpendicular bisector, join the corresponding points, draw the perpendicular bisectors. Where the bisectors meet, that's the center of rotation. Now it says shape B is an enlargement of shape A. So A is there, B we have to draw. The center of enlargement is 5, 5. And the area of the shape is 27. Draw shape B on the grid. Okay, now first of all, we have to figure this out, that this is like 1 and this is like a 1 by 1 square. So this has an area of 1, this has an area of 1, this has an area of 1. So area of A is 3. Area of B is 27. So we know that area of B should be K squared times area of A. This is 27, that is K squared times area of A, which is 3. K square is 9, therefore K is plus minus 3. And they are not saying anything about the plus minus 3, so I'll just stick with the plus sign. Now the center of enlargement is 5, 5. So the center of enlargement is 5, 5. Now this is center of enlargement, COE. That means there is no space in the grid to go this way, so I have to go this way. So now the rule is, if the center of enlargement is positive, we have the center, then the original, then the final shape. So that's the order in which it will go. If it was negative, the object would be over here, the image would be on the other side. So now the scale factor is 3. That means you have to do some counting. So 1, 2, and then 1 down. So that will give me this point. So let me mark this point, which is over here. And let me PQ, and let me mark this thing as R. Let me mark this thing as S, and so on. So go 1 left, 2 left, and 1 down. So from here, we have to do something else. Multiply it with 3. So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. You're going 6 to the left, and then 1, and then 2, and then 3 down. So somewhere here would be R prime. Got the idea? So now 1 point is done. You can do it with the rest also, but you don't have to. What you will do is this. This thing is 2 units long. So let me draw this thing as 6 units long. 1, 2, 3, 4, 5, and 6. This thing is now 2 units this way. So let me make it 6 units. 1, 2, 3, 4, 5, 6, like this. And then we have this thing that's 1 unit down. So let me make it 3 units down. 1, 2, and 3. And over here, this purple one is like 1 unit. So let me make it 3 units. 1, 2, and 3, like this. And another 1 unit over here like this. So let me make it 3 units. 1, 2, and 3. And the last one is just joining these two. That is like this. Got the idea? So that is how you would create this thing, which is image of B, the object B. So exactly over here, that is the concept. And the counting, I have done a much better job telling you people right now. So now over here, something like this. It says triangle A, B, and R are drawn on the line. A and B are triangles, line is R. Write down the equation of line R. So that's coordinate geometry. A line which is vertical is of the form x is equals to a constant, that value is 2. This is like 1, 2, 3 units from the mirror line. So it should be 1, 2, 3 units over here. This is facing this way. This will face this way. This is going down. This is going down like this. And that is a mirror image. Draw the image of triangle A after reflection. Describe fully the single transformation that maps A onto B. So A onto B. Again, the base becomes the height. The height becomes the base. This is negative 1, 2, and this is negative 2, negative 1. So look over here. This is, it's written over here. Negative 1, 2 becomes negative 2, negative 1. So the first the coordinates flip, then the x coordinate changes sign. First the coordinates flip, then the x coordinate changes sign. That is 90-degree anti-clockwise rotation about the origin. New x coordinate changes sign. Okay. This is again the same kind of transformation. And now let's take a small break. So let's take a break. It's exactly 1 hour since we started. So let's take a break of, let's say, 7 minutes. And to refresh, and then we will come back. So this is break number 1. So a break of 7 minutes, and let me just see you after 7 minutes. Take care, everyone. So people, welcome back. The first break is done. And yes, time passes very quickly. So now this thing, let me just double check. So now let me take you to some past papers. Let's go back somewhere over here. So now let's look at some 2022 past papers. And let's do some random questions. And if there is anything that needs a review, so we will come back to it. So let me just focus on something which is about probability we just did. And that's the first thing. Let me focus on the thumbnails. This one, actually, we already did this question. So now let's do this thing. Let's go through each question. I think this will save us time. Otherwise, we would be going for too much of perfection and we would be meeting almost all the things over here. So now over here, the first page, it says, write down the value of 5 in the number. So this is unit 10, 100, 1000, 10,000, 100,000. So 5 is 10,000. So value of 5 is 50,000. That's the first one. And let me just double check whether everything is set over here or not. So now over here, yes, it's all looking good. So welcome back. So now over here, the crowd at a sports event is exactly 35687. Write this number correct to the nearest 10. So this is unit, this is 10. So basically 87, is it like 80 or 90? So it's closer to 90. So this is 35690. 35690, that's the answer. Now let's talk about symmetry. Write down the number of lines of symmetry of this diagram. So there is only one line of symmetry because this is the only way in which it would fall over and overlap. Write down the order of rotational symmetry. So let me label this point as Q, this point is R. So if I rotate at 180 degrees, Q will take place of R will take place of Q, and I need 180 degrees more. So the order of rotational symmetry is 2. Let's talk about temperature difference, height difference. Yes, this is some people, they get really confused in this thing. It says the table shows the average monthly temperatures in degrees Celsius in this town, somewhere in Russia. So now over here, this is Jan, this is Feb, this is August. I've marked these three. Find the difference between the highest and the lowest of these temperatures. So the highest temperature is 20, the lowest is negative 12, 20 minus minus 12, that is 32. That's the temperature difference. In Feb, the average temperature in this another town is 37 below of town V. It's difficult to pronounce. Find the average temperature in this in Y in February. So now this is 37 degrees below V. And what is the average temperature? So that is over here. That is February. That is negative 8. So negative 8, negative 37, that is this much below, that is negative 45. So this is negative 8, and we are going 45 degrees to the left. So that comes, 37 degrees to the left. So therefore, this is negative 45. Now let's talk about mensuration, a nice question. It says two cubes have a total volume of 152. One cube has an edge of length 5. Calculate the length of edge of the other cube. So the first cube, 5 into 5 into 5, that's 125. So subtract 125 from 152, that is 27. That is x into x into x. X cube is 27, therefore x is equals to 3. So one cube has a length of 3, the other cube has a edge length of 5. Work out the total length of all the edges of the larger cube. So larger cube has a length of 5. There are 12 edges, so 12 into 5 is 60. Now, a lot of people, they get confused with Net's question. Now it says the diagram shows the net of a solid drawn on a 1 centimeter grid. That means this is 1 centimeter, this is 1, this is 1, that's 3 centimeters. The length is 1, 2, 3, 4, 5, 6. And if I take this width, or let's call this as the length, that is not exact because this is like 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 9 and something. Of course, it won't be exact because first of all, this is a cylinder. This is the top of the cylinder. This is the bottom of the cylinder. This is the curved surface area. The formula for curved surface area is 2 pi r h. So this 2 pi r, that is this. That is why this is not exact and this h is 6. Got the idea? So the diameter is 3. The radius is 1.5. It's a cylinder. That's the radius. That is the length. That's the length or the height. So now this thing is done. Something again with numbers. So write down a prime number between 10 and 15. Just write it down and pick it up. So now these are the questions that we are doing right now. They are technically easy. A little bit difficult could be the next question. So an irrational number between 10 and 15. So what is a rational number? That can be written as a fraction of two integers. What is an irrational number? That is square root of 2, square root of 3, and so on. So between 10 and 15. Now 10 square is 100. 15 square is 225. So anything between these two would be irrational. So square root of 10, 101 would be a little bit more than 10. So that would be irrational. 20 students were asked how many pets they owned. The responses are shown in the table. Number of pets, that is the frequency density distribution for discrete values. This is the corresponding frequencies. Now it says find the median number of pets. Now this 3 zeros means 1, 2, 3 is there. This one is written 8 times and this and this and this and so on. So first of all, 20 is the frequency that is divided by 2. That is 20 students. 20 divided by 2 is 10. Therefore, average of 10th and 11th value, that will give me the median. Got the idea? So now over here, you have to look for this. That is this thing, which is 3 plus 8 is 11. That means the 10th value is also 1. 11th value is also 1. This I have expanded and described this thing. So the median is 1 because it's the average of 1 and 1, which is 1. Calculate the mean number of pets, that is sigma fx over sigma f, multiply, 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 add it up, divide by sum of frequencies. And of course, this is paper one, so it's easily done. Fractions, very important. People know how to do fractions, of course, but just a word of caution, do not hurry in such questions. 3 and 5, that is the LCM is 15. 15 divided by 3 is a 5. 5 into 2 is 10. 15 divided by 5 is 3. 3 into 3 is 9. 10 minus 9 is 1. 1 over 15. Division, changing to multiplication. Don't forget to flip the fractions. Write the length in order of size starting with the smallest. Now this is a question of ordering. Now this question of ordering, what needs to be done is that first of all, make sure they all are in the same units. So that is the first thing that needs to be done. Now, when we say they all should be in the same units, So first of all, focus over here. What do we see? We see 32,000 centimeters. That's good enough. 3,300 millimeter. So cancel off a zero. That's 330 centimeter. 3.1 kilometer, multiply by three zeros to get into meter, and then multiply by two zeros. So technically, we multiply with five zeros. So 3.1 is 1, 2, 3, 4, 5. That is 310,000. And then 34 meter is 340 centimeter. Now, once everything is in the same units, then you decide which one is the smallest, which one is the largest. And first I have labeled the letters, and then I have written down the values in the original thing, in the original unit. That thing is done. Now, scatter diagram. We talked about statistics, and scatter diagram is part of that. So now over here, it says the table below shows the monthly rent for 9 apartments and the distance of these apartments from the city center. So now, first of all, when you do these questions, check this thing. Is it in a particular order? 0.8, 1.5, 2.7, 3.6, 2.0? No, it's not in a particular order. It's all jumbled up. Uh, what you do is that these four things might have been plotted. So it will say over there, the first 4 points have been plotted for you. So these first 4 points are plotted. The rest of the 5 points you plot. And what type of correlation is shown on the diagram? Since it has a negative gradient, so therefore it has a negative slope, a negative correlation. On the scatter diagram, draw the line of best fit. Now, first of all, we cannot aim for perfection. Whatever points are left at the top, that should be almost equal to the number of points left at the bottom. So this point, and no, just 2 points. And passing through these 2 points, and 3, 4 points are left at the top, 3, 4 points are left at the bottom, and that is good enough. Of course, there will be some human error involved, and one person's work will be different from the other person's work. So don't worry about that. Use your line of best fit to estimate the monthly rent for an apartment which is 4 kilometers from the city center. So distance from the city center, that's 4 kilometers. So look at the direction of the arrow. I'm using this value, touching the graph, going left, and that is the estimated value. That comes out to be 270. So far, so good. Now, these first 10 questions, if I focus on the number of marks, now keep in mind, there would be certain questions which would be out of syllabus. We'll just ignore that, like loci or matrix, but just focusing on the number of marks. So far, all the questions were part of the syllabus. So this is 1 plus 1 is 2, 3, 4, 5, 6, 7, 8, 9, and then 9 and 3 is 12, 12 and 13, 14, 15, 16, 17, 18, 19, 20, 21, 21 and 5, 26. So first 10 questions, 26 marks, they were easy enough. Okay. And they should hardly take like 15, 17 minutes. The maximum is 1 mark is 1 minute. Now, this question, coincidentally, we already did this. Now, this thing, the next question, that is about estimation. People ask a lot of things about this thing. It says, by writing each number correct to one significant figure, estimate the value of this. So 0.28 will be written as 0.3, 37.4, one significant figure. So focus on the second significant figure. So 37 lies between 30 and 40. So it's closer to 40. 77.8 lies between 70 and 80. It's closer to 80. So now this is again the second significant figure. For the first one, 0.28 lies between 0.2 and 0.3. So this is 0.3, this is 40, this is 80, this simplifies to 0.15. That is an estimation question. This one was already done. Okay, algebra. We all know how to expand. Just don't make any silly errors. Now keep in mind, this is expand and simplify. This is not an equation. There is no equal sign over there. Some people, they get really excited and then they equal it to something, zero most likely, and then they get the value. That's not what they're asking. Writing as a single fraction in such scenario, the very first thing that you need to do is that take this b common out. So b is common out, and then it's a simple fraction question. Standard form, yes, important. Nothing has to be taken lightly. So now write 00000863. So 000863, that is 1 and 2 and 3 and 4. Since you are yourself moving to the right, therefore it has a negative sign. So this is 8.63 raised to power of negative 4. That was a basic thing. The table below shows the approximate areas of some deserts. So this is desert area in kilometers square. Write down the name of the desert with the largest area. Calculate the total area of Arabian and Kalahari Desert. Give your answer in standard form. So now, first of all, this is power 6, this is power 6, this is power 6, Kalahari, power 5. So if I go 1 unit to the left, so that is 0.9 into 10 power 6. And similarly, this is 1.4 into 10 power 1 into 10 power 6, which is 14 10 power 6. Now, of course, this 14 is not in the standard form, but for comparison purposes, the powers of 10 should be equal. So once this is done, which one is the greatest one? That is the desert in Antarctica. That's news for me. So now the next one, the total of Arabian and Kalahari. So Arabian is 2.3, Kalahari is 0.9. So 2.3 plus 0.9, that's 3.2 into 10 power 6. And yes, it's in the standard form because the rule of standard form is A lies between 1 and 10. 1 is inclusive, 10 is not. Now indices, very, very important. 7 raised to power of negative 3 divided by 7 raised to power of negative 4. So that is 1 over 7 cube. This is 1 over 7 4. This is 7 4 over 7 cube, which is 7. Or you can also write it like this. 7, it's written over here. 7 raised to power of negative 3 minus divided by 7 raised to power of negative 4, negative 3, negative 4. That's 7 raised to power of 1. So your choice. Find the value of k when 3 raised to power of 6k is equals to 3 raised to power of 2. So 6 and k will multiply. So 3 power 6k, 3 power 2. Therefore, k comes out to be 1/3. Simplify, give your answer in this form. So this 3 is 3 power 1. This power 2 gets multiplied with this 2. That's power 4. 2 into 3 is 6. 2 into 4 is 8. 3 power 1, 3 power 6, 3 power 7. And that is the answer. Something to do with vectors. So now it says on the unit grid below, draw and label vector P. So now we can start from any point because the x coordinate, the x-axis and the y-axis is not given. So P is 2, 3. That means start from here, go 2 units to the right, 3 units up, that is P. On the unit grid below, draw and label vector 2q. So 2 times negative 3 is negative 6. 2 times 2 is 4. So that means start from any place, go 6 units to the left and 4 units down. Actually, this is negative 6 and 4. So 6 units up. Okay. So now there is the small mistake. So therefore, this should be 6 left and 4 up. So it should be like this. So now this is not drawn correctly. Let me correct myself. So therefore, first of all, let me start from here. That is 6 to the left. 1, 2, 3, 4, 5, and 6. And then 4 up. 1, 2, 3, 4. So that is the ending point. This is the starting point. And let me draw a green line like this. So I think I initially must be explaining negative 6, negative 4, or something like this. Okay, so now this thing is done. That is 2q. Now it says on the unit grid below, draw and label p minus q. So there is p, there is q, subtract, that is 5 and 1. That is easy. That thing is done. Scales and maps, something very, very important. Again, a basic numbering question. Now, a lot of these things in maths, they are related with what you call ratios. So now it says the scale of a map is 2 centimeters to 1 kilometers. The area of a wood on the map, that means a forest, on the map is 6 centimeters square. Calculate the actual area of the wood in kilometers square. So we don't have to use that usual thing that 1 kilometer is 1,000 into 100 centimeter. We are not using that. We are using this thing. That is the scale of a map. For example, the map of Pakistan is drawn and they write the scale 2 centimeter is to 1 kilometer. So now this is the map. This is the actual 2 centimeter is 1 kilometer. Square both sides. That means on this map, 4 centimeter square is 1 kilometer square. 6 centimeter square is W. So W comes out to be 1.5 kilometer square. Sets in Venn diagram. In the Venn diagram, shade the region represented by P intersection Q complement. That means Q complement is outside of Q, that is this and this, but common with P. So common with P is this thing. Now, this one was a nice question. We solved this question that day in the workshop. It says a club has 32 members. 14 of the members are female. So 14 are female. So everything inside should be 14. 18 are male. Okay, there is no box, there is no circle for male. 5 of the female have black hairs. So this is B for black hair. So this 5 will come over here. And 6 of the males have black hair. So this 6 will come also in black hair. So black hair people are 11. Now that is 18 minus 6 is 12. There are 12 people who don't belong to these categories. These are males without black hair, some other colored hair. So they fall on the outside. Circle properties, very important. So now over here, let me give you a brief idea of circle properties and then I'll go up. So now let me see if I have that thing handy of circle property. This is transformation, that is done. Vectors, let's ignore it for right now. Trigonometry, mensuration, geometry. So now in geometry, the properties are not written over here. Let me just briefly give you the overview. Now I have to look for the thing. Okay. So now over here, we know the basic properties. That is the circle, the chord produces angle. This chord produces angle. So these two angles are the same. So what we will say is that the chord produces angles in same segment are equal if produced by the same chord. And then the angle at the center is twice the angle at the circumference. That is necessary. If it's a four-sided figure, if it's a quadrilateral and all the vertices are touching the circumference, opposite angles are supplementary. This is a tangent. This is the angle that this chord makes with the tangent. And now this chord makes this angle at the circumference up till here. So if this is the case, that's an alternate segment theorem. Let's have a good look. So now over here, what we can do is that, first of all, find angle DEG. So D, E, and G, that should be 75. That the 75 angles in the same segment are equal if produced by the same chord. Angle DOG, if they are asking for this DOG, that is 2 times 75, that is 150. If they're asking for the reflex DOG, that is 360 minus 150, which is 210. Now it says find angle DBC, which is DBC, that is D and B and C, that is this thing over here. Now, if this is 210, The same property, half angle, that goes over here. This comes out to be 105. First of all, this was 150 and 75. That is in the major segment. This reflects angle 210. Half of that is 105. That's right over here. 105 plus 48. Add it up, subtract it from 180, and we find this thing. Functions. It says fx is 6x plus 2. Find f of 3. So just plug in 3. Evaluate. That is f of 3. Find f inverse of x. Let y is equals to fx. Therefore, f inverse y is equals to x. Instead of fx, write y. Make x the subject. But since x is f inverse of y, this is f inverse of y. We have a habit of writing everything in terms of x. So that is 5x minus 2 over 6. Y is inversely proportional to x plus 1 whole square. Given that y is 2, x is 3, find y when x is equals to 9. So y is proportional. In the proportionality with a constant of proportionality, plug in 2 and 3. X is 3, y is 2. X is 3, y is 2. You find k, you write down the equation. Now you can plug in x, you can find y. Now you can plug in y, you can find x. Basic factorization, 5ax minus 3ay minus 10cx plus 6cy. So from here, let me take a common. From here, let me take c common as well as 2 common. So now this thing on the inside comes out to be the same. This is factorization. And then these two are taken common. And this is the answer. Stop over there because this is factorized. It doesn't say solve. This is middle term factorization. So 15 into 4, that is 60 with a negative sign. Break this up. So that is 12 fives are negative 12 plus 5x. Again, from this point onwards, this is the same thing as this. Algebraic manipulation, make x the subject. Cross multiply, open up the bracket, gather all the terms with x on one side, take x common, that is the subject. Matrices, no more part of the syllabus. Now this vector question, that's a nice one. Let me add a page over here. I want you people to try it out first. So try out this question. Let me minimize it and let me close the voice so you can comfortably copy it and try it. Acha ji, let's get started. So now this question is about vectors and it says the following. In the triangle ACD, B is the midpoint of EC. B is the midpoint of AC. E is the midpoint of AD. E is the midpoint of AD. AB is this much. So if AB is given, BC should be the same. DC is 5A plus 2B. DC is 5A plus 2B. Express as simply as possible in terms of A and B, AC, AD. So we have to find AC, that's AZ and AD. So that means if I have this whole thing, I can find this thing and then do the half, taking care of the plus minus sign. Show that EB is parallel to DC. So that's the concept of scalar multiple. So remember these words. If I say if EB is parallel to DC, therefore it's necessary that EB divided by DC should be a constant. This constant is called scalar multiple. So let's get started. That's over here. First of all, this thing, AB and BC is the same. So therefore, AC is 2 times AB, 2 times this much. That is 12A plus 6B. AD plus DC is AC. AD plus DC, that is AC. AD plus DC is AC. Therefore, AD is AC minus DC, which is 7A plus B. Show that EB is parallel to DC. So we know that AE is half of AD. So we have AD. Take the half of this thing, that is 7 over 2A plus 4 over 2B. That is 7 over 2A plus 2B. Now, again, apply the concept AE plus EB is AB. AE plus EB is AB. So therefore, AB minus AE, that comes out to be this thing, 5 over 2A plus B, which can be written as 5A plus 2B over 2, which is half of 5A plus 2B. Isn't 5A plus 2B the same thing as DC? Yes. So therefore, since if I divide, I get this constant half. This is a scalar multiple. Therefore, it's parallel. That is the logic that is being applied over here. Got the idea? So now let me ask this question. If they ask us about area of small triangle to the area of big triangle, I would say 1 is to 2, the whole thing square. That is, the small is 1, the whole is 4. If the whole is 4, that means this much, the trapezium is 3. So therefore, if they ask for area of small triangle to trapezium, that is 1 is to 3. That can also be asked. Okay, so that is one paper. Now let me go to some specimen paper of last year. So now these were practice papers and then there were specimen papers. They were nice ones. So let's also go through these ones. So now let me just check for any comments or something. Okay. Okay. So now let's move ahead. It says calculators must not be used in this paper. And then it says write down the order of rotational symmetry. Now this is like one thing, this is like the other thing, this is like A, this is like B. So rotational symmetry is order is 2. And then there are some basic questions. Let me just remove those ones, skip those ones. Something like this, mensuration. Calculate the area of the trapezium. So this is 11, this is 7, that's sum of parallel sides, 11 plus 7, that's the height. Write 1 over 20 as a percentage, 1 over 20 into 100, that is 5%. Write this thing as a fraction. So recurring was added last year. So this is 0.2 with a dot. So this is 2, 2, 2, 2, that is recurring. So let x is equals to this thing, multiply by 10. So this 0, this pointer will move over here and the same thing will appear. So as soon as the same thing appears over here, so 10x minus x, that is 9x. 9x equals to 2. Therefore, x is 2 over 9. Something like this. Describe a single transformation that maps A onto B. So this is A. This is becoming B over here. Now the height becomes the base. Base becomes the height. Look at this. This is 2 comma 1. This is minus 1 comma 2. No change except for flipping things, stuff like that. So therefore, this is 90-degree anti-clockwise about origin. Triangle A onto C. So triangle A sliding onto C. So just take this point, 1, 2, 3, and this 4, 5, and 6, 6 units to the left and 3 units down. So 6 to the left, 3 units down, or the original plus the translation vector is the final, and then do the subtraction, you get the same answer. Triangle A onto triangle D. Triangle A onto triangle D. This height is 1. This height is 3. Scale factor is 3. Now, what is the center? Join corresponding points. Extend. Join corresponding points. Extend. Join corresponding points and extend where it intersects. That is the center of enlargement. Something to do with percentage. Roberto buys a toy for $5. He sells the toy for 4.60. That means he's making a loss of 0.40. Divided by the original, which is 5 into 100, and you get the answer. That is 8% loss. Fractions, that is simple. Yes, write 216 as a product of its prime factors. That's 6 into 6 into 6, which is 2 into 3, 2 into 3, 2 into 3, which is 2 cube into 3 cube. Now, this one was a tricky question. Now, when you come across something very difficult, even it could be in the beginning of the paper, so don't waste time on it. Leave it, come back to it at the very end. Now it says two positive integers are each greater than 25. The lowest common multiple of these two integers is 216. The highest common factor of these two integers is 18. So 216 is this thing. 18, that is 2 into 9. 9 is 3 into 3. That's 2 into 3 squared. So this is the LCM. This is the HCF. Find the two integers. Now they're greater than 25, 26, 27, 28, 29, 30. Now I want those which has 2 and 3 in it. So this is 2 into 3 into 5. Because of the 5, that's not applicable. Otherwise, 5 would have shown either over here or over here. 36 makes sense. That is 2 square into 3 square. Keep on going. 42, not worthwhile because of the 7. 48, 2 power 4 into 3. Now, if I compare these two, it's not giving me this answer of LCM or HCF. Let me write 54, that is 2 into 3 cube. Let me write 60, not applicable because of the 5. 66, not applicable because of the 11. 72 is 2 cube and 3 square. Now, if I compare 54 and 72, so 3 cube and 3 square, that is 3 cube, and 2 and 2 cube, that is 2 cube. So yes, that's giving me the correct LCM, the correct HCF, and these two are the answers. Another question of circle property, that was straightforward. There is P, there is Q, add it up, find the magnitude, that is using Pythagoras. Similar triangles, very important. Now the diagram is drawn, this red and this red, this blue and this blue, this cross and this cross. So just focus on this. This is 6, this is 12. So the ratio of small to big is 1:2. The area of the triangle PQR, the area of ABC is 15. So area of PQR should be multiplication by something. So area of small, area of big, length of small, length of big, the square. So 15, area of big, half square. Therefore, area of big is 60, which makes sense. So always make sure that your answer should make sense. The triangles are cross sections of prisms, which are also mathematically similar. The volume of the smaller prism is 300. Calculate the length of the larger prism. So now this is volume of small, volume of big, 1:2 whole cube. So volume of big is 2400. The volume of the smaller prism is this. Calculate the length of the larger prism. Do we have the cross-sectional area of the larger one? The cross-sectional area is this one. So yes, it's a nice question because this answer follows through without any hints or something. So therefore, the length is 40. Another nice question. Fx is 3x plus 2. Gx is x squared plus 1. Hx is 4 power x. Find h of 3. So h of 3, just plug in the value 4 raised to power of 3, which is 64. The domain of fx is this much. Find the range of fx. So the domain of fx, what we can do is that plug in -4, we get -12 plus 2, -10. Plug in 4, 3 fours are 12, 12 plus 2 is 14. So this value is giving me this lowest value. This is giving me this highest value, lowest till the highest. That is the range of a function. F of g of 1, what we can do is that first evaluate g of 1, which is 2. F of g of 1 is technically f of 2, and then you get this answer. Similarly, getting a composite function in this form. So g of f of x. What is gx? X squared plus 1. What is g of f of x? F of x, the whole thing square plus 1. And then you get this thing. Find f inverse of x. That is the same procedure. Y is equals to fx. F inverse y is equals to x. Make x the subject. Replace it with f inverse y. Therefore, f inverse x is x minus 2 over 3. Inequality. This thing, x is greater than or equal to 2. So this is x is equals to 2. It has to be the right of this. Y is greater than or equal to x. That is y is equals to x. It should be above this line. 2x plus y is less than or equal to 8. It is necessary that both these terms should be, the y term and the x term should be on the left, or at least y should be on the left. So just draw this thing, and with perspective of y, we would read y is less than or equal to something. So that is the green line below that. So to the right of red, above the blue, lesser than green, this is the shaded region. Something to do with tree diagram. Tanya plants some seeds. The probability that the seed will produce flower is 0.8. When a seed produces flower, the probability that flowers are red is 0.6. When a seed produces flower, the probability this is red is 0.6, yellow is 0.3. Tanya has a seed that produces flower. Find the probability that the flower are not red and are not yellow. So this is 0.6, this is 0.3, that is 0.9. So 1 minus 0.9 is 0.10, other colors. So produces flower, yes and no. Color red, yellow, other color. So Tanya chooses a seed at random. Find the probability the seed produces red flowers. So it has to produce flower and it has to be of red color. So this is 0.8 into 0.6. That is the answer. 8.8 can be written as 8 over 10. 0.6 can be written as 6 over 10. 8 into 6 is 48. 48 divided by 100. So that is an easy, sure, short way of checking the answer. Uh, Tanya chooses a seed at random. Find the probability that this seed does not produce red flower and does not produce yellow flowers. So now, first of all, this thing also has to be considered. That is not producing any flower at all. So not red, does not produce red, and does not produce yellow. So that means some other color, 0.8 into 0.1. Or it's not producing flower at all. So if it's not producing flower at all, there is no possibility of any color. So this is 0.08 plus 0.2, that's 0.28. So now let's talk about this thing, that is upper bound, lower bound, something very, very important. Everything is important. That is the first thing that you need to realize. And after this question, I'll go through the examiner report also. So now it says Ella's height is 175 centimeter, correct to the nearest 5 centimeter. Write down the upper bound of Ella's height. So this is the rule that you need to remember. That is, if they ask about any nearest integer, add and subtract half of 1 because the smallest integer is 1. So add and subtract half of 1. If they talk about any nearest one decimal place, so that is 0.10, divide by 2, add and subtract. If they ask about the nearest 5 centimeter, add and subtract half of 5. So now over here, the question is, Ella's height is 175 and write down the upper bound. So the upper bound would be 175 plus 2.5. If they would have asked for the lower bound, 175 minus 2.5. Now it says Raphael's height is 161, correct to the nearest unit. So 161 plus zero point 0.5, that's the upper bound. 161 minus zero point 0.5, that is 160.5. Work out the upper bound of the difference between Ella's height and Raphael's height. So if it's a difference between Ella and Raphael, Ella is taller, Raphael is shorter. So this is taller minus shorter. So we want a bigger value. So take the bigger value of Ella, which is the upper bound. Take the lower value of Raphael, which is the lower bound, and subtract, and that is the answer. If they would be asking for the difference lower bound, then it would be Ella lower bound minus Raphael upper bound. So Ella lower bound would be what? That would be 175 minus 2.5, which is 172.5. 172, 172.5, that is Ella lower bound minus Raphael upper bound. What is Raphael upper bound? That is 161.5. 161.5, and that would be the answer. Kinematics. The diagram shows the time of Sam's journey from home to work. This is a speed, this is a time, this is in seconds, this is in meters per second. Calculate the acceleration for the first 20 minutes, 2 minutes. So 2 minutes is basically 120 seconds. So basically it's asking about the straight line. If they would have asked for 60, still I can calculate the gradient. Any point in between, the gradient will be the same because this is the concept of collinear points. So now over here, that thing is there, meter per second square, no big deal. Calculate Sam's average speed for the whole journey. Give your answer in meters per second. So now give your answers in meter per second average speed. That means I need the total distance divided by total time. So total distance, either you can do the triangle, the rectangle, the third triangle, that's one thing. Or half sum of parallel sides, 120 and 480, the difference is 360. 0 and 600, the difference is 600, and the height is 20. So half sum of parallel sides into height multiplied by half, that is the total distance, divide by 600, the answer comes out to be 16. Now let's look at this question. This is a nice question. It says solid cylinder has a radius x and height 7x over 2. A solid sphere has radius capital R. The surface area of the sphere is equal to total surface area of the cylinder. Find an expression. Solid cylinder, radius is x, height is 7x over 2. Total surface area, 2 pi r square plus 2 pi rh. So let me take 2 pi r common. This is r plus h. Instead of r, let me highlight it. Instead of r, I have written x. Instead of r, I have written x. Instead of h, I have written 7 over 2x. And overall, this answer comes out to be 9 pi x square. The solid sphere has a radius of capital R. The surface area of the solid sphere is 4 pi capital R square. So now equate 4 pi capital R square with 9 pi x square. So therefore, R comes out to be 3x over 2. This is a proportionality inverse. So it would be written in the denominator. First evaluate K. Rationalization, very important. Simplify fully by rationalizing the denominator. So root 6 plus 1, multiply it with root 6 minus 1, root 6 minus 1. And then some vector thing, I think it's the same kind of thing as before. Solve x over x minus 4, 9 over x plus 1 is equals to 2. So this x multiplied with x plus 1, this 9 multiplies with x minus 4. The LCM is these two. Open it up, multiply, open it up, you get thing, which is quadratic middle term factorization, you get two answers. So now I think that's more than enough of all these things. And let me go to the examiner report of this thing. I think it's somewhere over here. Let me just examiner report. Okay, O Maths Life. Okay, that's the 2025 one. So now people don't worry much about the threshold and everything. Just focus on the main things that's over here. Let me just clear it for you and let me focus on this. So now people, we have done a lot of work in these 2 hours. And I think for right now, 2 hours are good enough. First thing first is that, let me write it for myself, show all working. Uh, Simplify steps, read carefully, uh, logical reasoning, logical steps, simplify steps, logical steps, and what you call this is paper one. So either it would be about fractions, either it would be about surds, take care of plus, minus, multiplication, division, all these things. And basically, whatever you have done, just realize what exactly needs to be done. So now over here, let me start highlighting it. To do well in this paper, hold for a second. Candidates should be familiar with the whole syllabus because they ask you everything. Now, this is a paper one, including all new content, recurring decimals, sketches, exponential, and so on. Know which formulas are given in the question paper. Yes, you should read that thoroughly, and which they are required to recall. Be able to carry out basic calculations without a calculator, very important. Understand and use correct mathematical notation. Draw accurate graphs and diagrams. So graphs can come in paper one, come in paper two. Be able to give clear description using correct mathematical terminology, something like the angle property, something like the transformation, and so on. Set out the work in clear logical steps. So I have written it over here. That is the logical steps, that is simplified steps, that is show all the working, read carefully. In general, candidates found the paper accessible and most attempted all the questions. They were well prepared and demonstrated, vagera, vagera. Candidates need to be able to understand and use mathematical notation required by the syllabus, such as vector notation, such as recurring decimal notation. They should read the question carefully and ensure they follow instructions. That's the main thing, such as giving the answer in a fraction in a simplest form, in terms of pi, or as a cert in the simplest form. Candidates usually demonstrated a strong grasp of arithmetic, although arithmetic errors were common when dealing with fractions and negative numbers. When calculating with fractions, candidates are advised to cancel first to avoid the need for complex multiplication. Um, then there were sign errors when rearranging equations. Just take care of that. Most candidates showed clear and methodical working so that partial marks could be awarded if the final answer was incorrect. This is the most important wording. Steps were often presented in a logical order. Candidates are advised to start working at the top of the available space so that they have sufficient space to show the complete method. Any working that is continued elsewhere should be clearly identified with the question number. Candidates are reminded of the importance of reviewing the work carefully to minimize avoidable mistakes such as arithmetic errors, sign errors, transcription errors. Diagrams were often clearly drawn. However, candidates are advised to use a ruler when drawing lines. Of course, you need a ruler to draw a line. Candidates should use a sharp pencil so that lines and points are positioned accurately. Very important. They should take care to write the figures clearly. For example, sometimes it was difficult to distinguish between the letter 1, the letter 4, and the letter 7. When several attempts have been made at the solution, the rejected method should be clearly crossed out. To make sure intended solution are clear, candidates should not work in pencil and then overwrite in pen. This often leads to illegible answers. So basically, that is more or less the story. And this is all the examiner report. Every single question explained in detail. From my side, what I will tell you is this thing, that just stay calm. That is the first thing. So you have to stay calm. Get a good night sleep so that your mind is relaxed. Because no matter how many questions you have tried earlier, it all boils down to exactly what you are doing at that time. Do not study the night before, or let me remove the night. Do not study in the morning before the PM paper, because your paper is in the afternoon. So do not study in the morning. Of course, don't flip through the notes. That is my advice. That is what I practice. Don't flip through the notes because you have to stay calm. Don't overthink. Don't compare yourself with others. You have done your hard work. You are all set. You're all set to for success. And what else? That is basically that you should feel confident about yourself. Don't underestimate yourself. Speak positive, very much positive about yourself. And what else? Eat very, very light before exam. After exam, what you can do is that you can try things out and you can eat as much as you like, but before the exam, just relax a lot. And what else is there? So now this thing is there, that speak this thing, and eat very, very little before exam. So that is little over here. And what else? Something like a candy bar, something like a chocolate bar. Take it with you and go in the exam center so that that sugar rush will help you out. So that is a little bit from my side, signing off, and see you for the paper 2 session. So lots of good luck for you all. Take care, everyone. And if you want to ask any question, you can ask in the comments or you can ask me by WhatsApp. Take care, everyone, and Instagram also.